The next topic is learning representations from data. So, in order to do a machine learning process, there are three points we have to remember. So, first one is we need to take care of what the input data is about and what is our expected output, and then the performance measure. So, if suppose in the first category what the input data is about, if suppose the application that we are interested to is for speech recognition, definitely our input data will be the audio or digital, that is digital or analog signals. So the sound files will be the input. And for example, if suppose it is a image tagging application, definitely the input will be pictures, that is the images. And for these two examples itself we can see what is the expected output is. So in case of speech recognition, the output will be definitely a text format, that is transcripts or text is the output. And for images, definitely the output will be what that object is present in that image. So the exact labels will be the output. So when we come for the performance measure, this is the important thing that we have to consider. So this only gives us awareness about how well our algorithm is working. Only if we measure the performance, we can be able to identify how well it performs or how good the accuracy is. So this can be done only by finding out the difference between the current output and the expected output. So only if we find this difference, we can find what is how much far the difference is. It will give us the feedback signal, and with that feedback signal we can again feed that feedback into the algorithm. And by doing this in an iterative manner, we can do the learning process in a better way. So only with the help of this difference we can improve the accuracy of our algorithm. So in both the machine learning and deep learning, meaningful representations of the data, so how well we represent our data in order to get the expected actual output as the expected one. So that is the main thing that we have to concentrate. So it is not based upon how accurate you are doing the prediction, but our ultimate aim is to get a good accuracy. But how it can be done is only by making useful representations of the input data, so that it will be directed to have a very clear expected output. So that is our ultimate aim. For example, this can be easily explained with an example. Suppose if you are having a color image, so you imagine that you are having a color image in your hand, and it can be there are two various different formats of representing a color image. So let us assume that it may be either RGB or it may be either a HSP image. So RGB, in R stands for red and green stands for G stands for green and B stands for blue. And here HSB format, in a sense, H represents hue, S represents saturation, and V represents value. So these are the two formats that I'm going to consider here. And suppose if the problem is selecting the red pixels of the image, if suppose the first problem in hand is selecting the red pixels of an image, definitely we need to have this color image in which format? In RGB format. Only if we have that image in the RGB format, we will be able to answer this question, that is select all the red pixels in the image. Suppose if we are having another one example, such as make the image less saturated. If suppose this is the second question, definitely we need to have this color image in the format HSP format. So how I am representing my image, based upon that representations only, I can get a very clear output for the question that is asked. So whatever the problem is, only by making the useful representations of the input data, I can get a very clear expected output. So this is called the representations of the input data. So here we can take on, let us consider one example where I have represented x and y coordinates and different types of points is given here.